All right, so in this video, we're going to be graphing a function by plotting points. Actually, we're not going to be plotting points because plotting points involves doing it by hand and plotting individual points. I'm going to show you a different process. This is going to be a quicker process using technology. So there's a link at the bottom of the slide that you'll see below this video link. That you access this video from. It's a Desmos for an online graphing calculator. If you go to that link, you can follow along and see what we're doing here. So first off, the domain of a function, because we want to state the domain of each function. The domain of a function is the set of all real numbers for which the function makes sense and yields real numbers. So we'll kind of recap this in a little bit after we look at the graph of a function. So we've already discussed domain for ordered pairs. Now we're going to be looking at the domain of an actual function rather than a relation. Of ordered pairs, we're going to be looking at an entire function. So graphing a function, we're going to be using Desmos. Let's look at that, and then we'll come back to the domain in a little bit. So I'm going to go ahead and graph each of these. Let's just start out with the first one, 2x minus 3. And I'll pull up the graphing calculator here. And we have, again, the bottom link in this slide will bring you to this site, desmos.com/calculator. So we have 2x minus 3. You type that in, and you can get this graph. And we'll notice if we zoom out, we keep zooming out. And you should be familiar with linear functions like this, but you'll notice that it goes up. It's just a straight line that goes forever in this direction. So the domain, again, I'll just read it again. The domain of a function says, unless otherwise stated, the domain of a function is the set of all real numbers for which the function makes sense and yields a real number. So that means you can plug a number into the function. So plug in a number into 2x minus 3. So for example, we can plug in 1 into this function. 2 times 1 minus 3 is -1. And we can get a real number out of the function. It yields a real number. So 1, what we plugged into the function, is part of our domain. It's what we can plug into the function to get a real number out. So notice that the numbers we're plugging in represents the horizontal axis. It's what numbers are along the horizontal axis. And we'll see that any number can be plugged in to this function because the graph exists for all numbers on the real number line because it keeps going forever down to the left and up to the right. So all real numbers are part of our domain. Okay, so let's go ahead and look at the next function. Let's go ahead and just stick with one function at a time. So that, because if we do more than one function on one plot, we'll end up being a mess. So we'll delete that, and we'll go to 2x squared. We're doing part B now. 2x, and then what you can do here is hit shift and then a 6, and it has that caret, and you'll be in the exponent form. You'll notice it just did something when it did shift 6, and you hit 2. You have a square now, and then you can hit the right arrow, and you'll notice that I'll move out of the square, and it'll have a bigger cursor. So I'm gonna hit the right arrow right now. There we go, and then we subtract 3. Okay, so there we go. Let's zoom in a little bit to see what's going on. Okay, so as you can see, it's going down and then coming back up. Now, I want to discuss range on this problem. Range, it's not defined on the slide, but keep in mind that you may be asked about range. Now, the range is what values can you get out of the function. That represents the vertical axis. So the horizontal axis represents what values you can plug into the function. It's the x-axis. The output is the y-axis. It's what you can get out of the function. So notice, if you zoom out again, it goes up to the left and up to the right forever. So the domain is actually all real numbers, because it keeps going to the left, up to the left forever, and up to the right forever. So left to right, you'll always be able to plug a value in to get a real number out. So the domain in this case is all real numbers. But we notice that the range is what values can you get out of the function. Notice that we cannot, if we zoom in here, notice that there's no values. If I move this around, we can see that there's no way I can get a value below -3. -3, there's no output. So the range for this is from -3, and then it goes up forever. So it's from -3 to positive infinity, because it keeps just going up forever. So the vertical axis is the range. So notice that we don't have any numbers down here, so there's nothing down here as part of our range. The range is actually from -3 to infinity, positive infinity. Okay, so now let's move into part C, which is 2 times, and times is shift 8, if you didn't realize that that's star, shift 8. That's how you bring up this dot here for times. And then square root is SQR, and then when I hit T, SQRT, it's the abbreviation for square root, it'll turn into a square root. T, there we go, SQRT. And I believe if you pull up this calculator, you'll have some, some different tools to use. So you can actually use this down here if you want. So I could have, let's delete that. I could have just done square root and clicked on that and pulled up the square root. And here's multiplies and a lot of different things in here. Anyways, I'm not going to use that anymore. So x, square root of x. And now the rest of what I want to write is not under the square root. So I want to hit the right arrow. And so I notice I'm under the square root. Now if I hit the right arrow, it'll move out of the square root. I'm out of the square root now. Right arrow will move you out. -3. There we go. Now let's move this over a bit. Maybe zoom out a little bit. We'll notice that it just goes off to the right forever. And it goes up to the right. It'll keep going up, keep going up. Okay, so we'll zoom out to maybe see it a little more. Okay, there we go. Notice that the domain, in this case, goes, it's the horizontal axis. It goes from 0, zoom in again. It goes from 0 to infinity. So that's the domain. It's a horizontal axis. Horizontally, we can see it goes from 0. The inputs go from 0 to infinity. So that's the domain, 0 to infinity. And horizontally is domain. Vertically is range. So 0 to infinity. And that makes sense because you cannot plug in a negative number into a square root. Okay? You cannot plug in a negative number. Square root of a negative number, as you may know, is a complex number. It's not a real number. So it's not in your domain if you're taking the square root of something negative. Okay, so but 0 is okay, and everything above it is. So from 0, including 0, to infinity is part of your domain. And now the range, we'll notice that it actually goes from -3 to infinity. Let's just double check that here. So we actually see, if we zoom in a little bit more, it goes from -3 and then it goes up forever. It keeps going up. It ends up being pretty flat, but it is always going up. It's always going up, and you'll never stop going up. Okay, so that's from -3. Remember, vertical, the vertical axis. The vertical axis is range. So -3 to infinity, up to infinity. -3 vertically. So vertical axis, -3 to infinity. All right, let me know if you have any concerns about domain and range and how to graph with Desmos. It's one of the best online calculators for graphing that's out there. So anyways, let me know if you have any concerns. I'll be more than happy to help.